Welcome to the Oracle EPBCS PBCS Implementation Playbook. This video is your comprehensive guide for delivering successful Oracle Enterprise Planning and Budgeting Cloud Service projects. Whether you're a solution architect, functional consultant, technical lead, or part of the delivery team, this playbook is designed to help you navigate every phase of implementation. We'll cover proven methodologies, best practices, and real-world insights from global enterprise projects. By the end, you'll understand how to drive planning transformations, align teams, and ensure robust governance. Let's begin by exploring the foundational principles that underpin Oracle EPBCS PBCS implementations. Guidance in this playbook is built on Oracle's EPBCS PBCS implementation methodology, official EPM Cloud documentation, and readiness guidance. It incorporates Oracle's best practices for planning transformations and draws from real-world experience across global organizations. This ensures you're equipped with both theoretical frameworks and practical insights. As we move forward, you'll see how these sources inform each phase of the implementation, providing a solid foundation for enterprise-scale planning projects. This playbook covers every stage of the EPBCS PBCS implementation lifecycle. You'll learn about initial requirements gathering, design and build, testing and user acceptance, deployment, and go-live cutover. We also address AI and automation recommendations, delivery models, specific do's and don'ts, architect guidance, and cross-phase governance. Each section is structured to provide actionable steps, documentation requirements, and practical advice, ensuring you're prepared for every challenge and opportunity. Initial requirements gathering phase is critical for understanding enterprise planning and forecasting needs. This stage aligns finance, operations, workforce, sales, and strategic planning processes. It defines the project scope, governance, and operating model while establishing the future state planning architecture. Identifying automation and integration opportunities early helps reduce downstream redesign and rework. Let's explore the objectives and key activities that set the foundation for a successful implementation. During requirements gathering, the main objectives are to understand planning and forecasting requirements, align all relevant business processes, and define the scope and governance model. Establishing a future state architecture and identifying automation and integration opportunities are also key. This phase aims to minimize future redesign and ensure a clear path forward. By focusing on these objectives, teams can build a strong foundation for the subsequent design and build phase. Business process discovery workshops are essential for gathering detailed requirements. These workshops involve corporate FP&A, finance controllers, business unit finance teams, workforce planning teams, sales and revenue planning teams, supply chain planning teams, treasury, tax teams, operation leadership, IT, ERP teams, and executive stakeholders. Engaging these groups ensures a comprehensive understanding of business needs and sets the stage for effective planning and forecasting. Understanding key business areas is vital. Planning and forecasting cover annual operating plans, rolling forecasts, driver-based planning, long-range strategic planning, scenario planning, what-if analysis, top-down versus bottom-up planning, forecast frequency, and planning assumptions. Financial planning includes revenue, expenses, capex, cash flow, workforce, project profitability, and tax dependencies. Operational planning focuses on sales forecasting, supply chain, demand, inventory, manufacturing, and KPIs. This holistic view ensures all critical business functions are addressed. Reporting and analytics are central to effective planning. Executive dashboards, board reporting, variance analysis, KPI scorecards, driver analysis, predictive insights, and regulatory reporting dependencies are all key components. Integration requirements include ERP, HRMS, CRM, data warehouse, flat file, API, and data synchronization frequency. Addressing existing pain points such as spreadsheet dependency, manual consolidations, planning cycle delays, and data quality issues is crucial for improving transparency and user adoption. Identifying existing pain points is essential for successful planning transformation. Common challenges include spreadsheet dependency, manual consolidations, planning cycle delays, data quality issues, lack of transparency, limited scenario analysis, inconsistent assumptions, weak governance, reconciliation challenges, and poor user adoption. Addressing these issues early helps ensure smoother implementation and greater business value. Documenting the current landscape is a key step. Technology assessment covers existing planning tools, ERP ecosystem, source systems, reporting platforms, data warehouses, integrations, and automation maturity. Process assessment includes planning cycles, budget timelines, approval workflows, governance, security model, forecast methodologies, allocation methods, and reporting cycles. Data and metadata assessment focuses on chart of accounts, entity structures, cost center hierarchy, product and customer hierarchy, workforce structures, and master data governance. Organizational assessment maps stakeholders, user personas, regional process variations, change readiness, training requirements, and support maturity. Future state design workshops define the target planning operating model. Enterprise planning architecture, standardized planning process, rolling forecast strategy, scenario planning approach, workforce planning strategy, driver-based planning framework, integrated business planning model, automation opportunities, AI ML enablement, security and governance model, and reporting framework. These workshops ensure alignment on the desired end state and set clear direction for the design and build phase. Mandatory functional documents include the Business Requirement Document, BRD, Current State Assessment, Future State Process Flows, Planning Requirement Matrix, KPI and Reporting Catalog, Workforce Planning Requirements, Driver-Based Planning Matrix, Integration Requirement Document, Security and Access Matrix, Metadata Inventory, Data Source Inventory, Planning Calendar and Governance Model, Change Management Plan, and RAID Log. These documents provide a structured foundation for the project. Technical and architecture documents are equally important. These include the high-level solution architecture, integration landscape diagram, environment strategy, data governance model, and planning model design inputs. Proper documentation ensures clarity, supports future enhancements, and provides a reference for troubleshooting and audits. Functional best practices include standardizing planning processes before customization, aligning global planning calendars early, rationalizing reporting requirements, minimizing spreadsheet dependencies, defining ownership structures clearly, standardizing planning assumptions, establishing KPI definitions centrally, confirming forecast cadence upfront, validating historical data requirements, and establishing clear planning governance. These practices help streamline processes and ensure consistency across the enterprise. Technical best practices emphasize defining integration architecture early, designing scalable dimensions and metadata, aligning planning models with future growth, planning automation from the beginning, assessing data quality before design starts, establishing metadata governance frameworks, and designing modular planning applications. These steps ensure the technical foundation is robust and scalable for future needs. Governance best practices include establishing an executive steering committee, defining a clear RACI model, implementing formal change management, creating weekly governance cadence, establishing an architecture review board, and defining issue escalation paths. Strong governance ensures accountability, timely decision-making, and effective risk management throughout the project. User adoption best practices involve business users early, conduct iterative DMOS, build role-based process ownership, establish a superuser network, and align change management with the implementation timeline. These practices foster engagement, facilitate training, and ensure smooth transition to new planning processes. Avoid replicating inefficient legacy planning processes, uncontrolled scope expansion, underestimating planning complexity, excessive manual adjustments, ignoring regional variations, unclear ownership definitions, and overlooking executive alignment. These pitfalls can derail projects and lead to costly rework. Awareness and proactive management are key to avoiding these issues. Technical pitfalls include over-customization, poor metadata design, ignoring future scalability, late integration decisions, disconnected planning models, and underestimating data governance needs. Addressing these risks early ensures a scalable, maintainable, and integrated planning solution. Delivery pitfalls include incomplete requirement sign-offs, fragmented stakeholder ownership, proceeding without executive sponsorship, insufficient change management, and unclear project governance. Ensuring thorough sign-offs, clear ownership, and robust governance helps maintain project momentum and accountability. Design and build phase translates business requirements into a scalable planning architecture. Teams configure standardized and supportable EPBCS PBCS solutions, develop integrations and automation, build audit-ready frameworks, and enable enterprise-wide collaboration. This phase is where the vision becomes reality, setting the stage for robust planning operations. Solution architecture design defines the planning application architecture, modular planning framework, workforce and revenue planning design, CapEx and strategic planning models, scenario planning architecture, driver-based logic allocation methodologies, integration and security architecture, and reporting architecture. This comprehensive approach ensures all business requirements are addressed in a scalable and maintainable way. Metadata and hierarchy design covers entity, account, cost center, product, customer, workforce, custom dimensions, scenario and version structures, and alternate hierarchies. Key considerations include scalability, performance optimization, reporting flexibility, future acquisitions, organizational restructuring, planning granularity, and user experience. Proper design ensures efficient data management and reporting. Planning logic and calculation design includes driver-based calculations, allocation methodologies, revenue forecasting models, workforce calculations, currency conversion logic, forecast spreading logic, smart push design, business rules architecture, and groovy automation logic. These elements ensure accurate, automated, and scalable planning processes. Integration design involves connecting Oracle ERP Cloud, SAP, Oracle EBS, NetSuite HCM Cloud, Salesforce CRM, flat files, data management exchange, APIs, and data warehouses. Teams define data load frequencies, validation rules, error handling, reconciliation processes, auditability, and data transformation rules. Effective integration ensures seamless data flow and reliable planning outputs. Security and workflow design defines role-based access, segregation of duties, workflow approvals, planning approvals, smart view access, security inheritance, data form security, and approval hierarchies. Proper security ensures data integrity, compliance, and controlled access throughout the planning process. Reporting and dashboard design builds executive dashboards, planning dashboards, variance analysis reports, KPI scorecards, operational dashboards, workforce reports, management reporting packs, and narrative reporting integration. These tools provide actionable insights and support decision-making across the enterprise. Automation and AI design implements predictive planning, AI-based forecasting, intelligent variance analysis, automated workflow notifications, smart data validations, machine learning forecasting models, and automated reconciliation logic. Leveraging these innovations enhances planning accuracy, efficiency, and responsiveness. Functional and technical documents required include the Solution Design Document (SDD), Technical Design Document (TDD), metadata design workbook, planning model design document, calculation logic document, allocation methodology document, integration mapping specifications, security design document, workflow design document, data validation rules, report inventory, test strategy document, and environment management plan. These documents ensure clarity and traceability throughout the design and build phase. PBCS design best practices include leveraging out-of-box functionality, minimizing custom calculation scripts, using configurable calculations before custom rules, standardizing planning assumptions, keeping dimensions governed and scalable, designing for acquisitions and reorganizations, using Oracle recommended metadata structures, and separating operational and strategic planning layers. These practices ensure efficient, maintainable, and scalable solution. Workforce planning best practices include standardizing employee assumptions, building flexible workforce drivers, aligning compensation models centrally, and enabling HR integration early. Revenue planning best practices focus on driver-based forecasting, standardizing revenue assumptions, enabling scenario comparison, and designing predictive forecasting models. These approaches ensure accurate and flexible planning for key business areas. Performance best practices include optimizing hierarchy depth, limiting unnecessary sparse dimensions, avoiding excessive custom members, optimizing business rules performance, and designing for concurrent planning cycles. Governance best practices focus on strict metadata governance, release management process, formal design approvals, and rigorous change request control. These ensure high performance and disciplined project management. Design pitfalls include over-engineering the planning model, unsupported custom logic, excessive smart view dependency, duplicating ERP logic unnecessarily, excessive metadata complexity, and disconnected planning models. Avoiding these pitfalls ensures a streamlined, maintainable, and integrated planning solution. Technical pitfalls include ignoring performance testing, excessive custom groovy logic, hard-coded business rules, weak security segregation, and poor integration error handling. Governance pitfalls involve proceeding without formal design sign-off, undocumented design changes, uncontrolled metadata modifications, and weak release governance. Addressing these risks ensures a robust and compliant planning solution. Testing and user acceptance phase validates business functionality, confirms planning accuracy, ensures performance and scalability, validates controls and audit readiness, and prepares business users for production operations. Thorough testing is essential for a stable and reliable planning solution. System integration testing (SIT) validates data integrations, planning calculations, allocations, forecast logic, workforce planning, revenue planning, workflow approvals, security access, reporting outputs, smart push functionality, and predictive planning models. This ensures all components work together seamlessly and meet business requirements. User acceptance testing (UAT) involves business users validating end-to-end planning cycles, forecast processes, budget submissions, reports and dashboards, data accuracy, workflow usability, performance expectations, and operational readiness. UAT ensures the solution meets user needs and is ready for production. Regression testing validates that existing functionality remains unaffected, planning cycle stability, integration consistency, security integrity, and reporting consistency. Performance testing covers large data volumes, concurrent planners, forecast processing times, reporting performance, smart view performance, and peak planning cycle loads. These tests ensure the solution is robust and scalable. Security and audit testing validates segregation of duties, role-based access, workflow approvals, audit logging, and data access restrictions. These tests ensure compliance, data integrity, and controlled access throughout the planning process. Required testing documentation includes the test strategy and test plan, SIT scripts, UAT scripts, defect log, traceability matrix, performance benchmark report, security testing report, test evidence repository, UAT sign-off document, and production readiness checklist. These documents provide structure and traceability for the testing phase. Testing best practices include testing real-life planning scenarios, edge case forecasting situations, acquisitions and reorganizations, workforce planning, scenario comparisons, predictive planning outputs, production-like data volumes, and concurrent planner activity. User adoption best practices involve early user involvement, hands-on workshops, role-based training, simulating real planning cycles, and establishing superuser champion. Quality best practices focus on strict defect governance, prioritizing critical defects, establishing defect SLAs, and maintaining traceability from requirements to testing. Testing pitfalls include testing only, happy path scenarios, insufficient data volumes, ignoring reconciliation variances, skipping performance testing, late user involvement, limited scenario testing, proceeding to production with unresolved critical defects, incomplete sign-offs, undocumented test evidence, and weak defect management. Avoiding these pitfalls ensures a thorough and reliable testing process. We shall wrap up this video here, and the next phases will be covered in the next video. That is Phase 4, related to implementation and deployment phase. Then Phase 5 related to Geolive cutover and handover phase, following which we shall cover other miscellaneous topics of AI and automation recommendations, preferred delivery model, and finally the architect's guide with do and don'ts of EPBCS implementation. Thanks for watching. Do look out for the next video.